Choosing metric measurement units. Okay, so we did one about the US standard units, our standard system, but now we're going to do the metric units. Metric units are not usually as familiar for students, so I did take a screenshot of the graphic below. You should be writing out some notes on these topics so that you know how the metric system works here. And even when we were doing the US system, you should have written notes on that one also. So in this one, we get three statements, just like we did before. So Elsa ate an apple that had a mass of about 140 blank. A piece of paper weighs about 22 blank, or was about 22 blank long. To wash her car, Kira used 25 blank of water. So we need to figure out what is a reasonable measurement or unit to put into these. So we scroll down here, and if you notice, oh, they did switch them around from when I took the picture. That's interesting. Oh, it's because of how they asked the questions. So the pictures are still exactly the same. I guess on the first one, when I took this picture, they had actually had this question first instead of last. So, or this type of question. So going through this, it says to measure capacity, we use milliliters and liters. So capacity is kind of like how much the volume, how much can fit in there. So a milliliter is about the volume of a small dropper, which is about 20 drops. A liter is about the volume of a large bottle of water, and that has 1,000 milliliters in it. And every milliliter has 20 drops. So definitely a liter is much larger than a milliliter. Let's see. Then we have to measure length, we use millimeters, centimeters, meters, and kilometers. So if you notice, these for capacity, they both said liter on them. We had milli, and then milliliter, and then liter. Now we have meters instead of liter, but we still start with millimeter, centimeter, meter, kilometer. They all say meter. So this actually works a lot better with the metric system. Our system doesn't do that, where it has the same word with just a word in front of it, like this, suffix. Prefix. So it doesn't have something like that. We have, inch, foot, mile. They don't sound anything like the other one. But with the metric system, they do work a little nicer as far as converting. So if I have 1 millimeter, which is about the thickness of a dime. So if I had a dime here, I could hold up a dime. I don't have one right here. A centimeter is about the width of a pen. And a centimeter has 10 milliliters in it. So every milliliter, if I multiply by 10, I get a centimeter. And then 1 meter is about the length of a baseball bat. So it shows her holding a baseball bat. And 1 meter has 100 centimeters in it. So if I say 10 times 10, I get 100. So each time we just multiply by 10. And that gets us the next one. So it works on tens and hundreds. Depends on how far you're jumping. So if I multiply 10 milliliters by, I keep mixing liters and meters up when I say it. 10 millimeters by 10, I get the 100 centimeters. So it just depends on what you're multiplying here. And then 1 kilometer is about how far you walk in 10 minutes. So 1 kilometer equals 1,000 meters. So again, multiplying by 10. So we multiplied by 10, we multiplied by 10, we multiplied by 10. So it's kind of this jump forward each time. Now we're going to look at, I didn't mean to scroll up so far. So now we're going to look at mass, or how much something weighs. So 1 gram is about the mass of a paperclip, and 1 kilogram is about the mass of a textbook, and 1 kilogram has 1,000 grams in it. So this time we went from meter to kilometers. That's all we're going from here is gram to kilogram. So that's why we went from 1 to 1,000. So 1 to 1,000. So each time we can multiply this number by 10, but to go from millimeter to centimeter, we multiply by 10. To go from centimeter, just 1 centimeter to meter, we multiply by 100. To go from 1 meter to 1 kilometer, we multiply by 1,000. So same thing with gram to kilogram. 1 gram, we multiply by 1,000, and that gives us a kilogram. So it's just one of those things we have to remember how to convert. So I'm going to leave this up here so we can reference it. And let's go to the next page so we can see. The other thing it's going to give us too, let's scroll up here, is there's a drop down. So there's a choice. So it says Allie's refrigerator has a mass of 75. We're either going to choose grams or kilograms. So 75 grams, do we think her refrigerator weighs 75 paper clips or 75 textbooks? Even 75 textbooks, I'm not sure that's quite enough. But we'll go with textbooks on that one because it's definitely not 75 paper clips for a refrigerator. Frank's desk is about 1 blank long. So we have these 4 choices. So if we think of a desk, we wouldn't want millimeter because that's only a dime, so it's not very wide. A centimeter is only the width of about a pen here. And then a meter, that's about, 3 feet. That's a bat. 3 feet long for a desk. Or a kilometer, which is how far you might walk in 10 minutes. So I'm hoping your desk doesn't take you 10 minutes to go from one end to the other if you're walking. So I'm going to go with meter on this one. All right. Martina poured about 9 blank of medicine into a spoon. So let's see. We have 2 options here. Milliliters or liters. So she poured 9 milliliters of medicine into a spoon or liters. Remember, a liter is a large bottle. So if she poured 9 large bottles into a spoon, she's probably going to make a huge mess. So I'm thinking it's milliliters. All right, we're good to go. Let's do one more of these. Okay, so the can of soda held about 360 blank, and we can go milliliters or liters. So 360 milliliters, so droppers, or 360 large bottles, liters. I don't think one soda can hold 360 large bottles. So I'm going to go with milliliters. Just sounds a little bit more reasonable. All right. Kareem bought a candy bar. Its mass was about 50. And we need to go to mass. So we're either going to go with grams or kilograms. So candy bar, do you think it's about the same as 50 paper clips or 50 textbooks? Because we have grams or kilograms. And I'm just comparing the object because it makes it a little easier in our head. I'm thinking grams. That makes a little more sense. If you bought a candy bar that's the same weight as 50 textbooks, wow, that is a lot of chocolate there. Assuming it's a chocolate candy bar. All right, the bee was about 13 blank long. So we can go with milliliters. So the bee was, if we go with a dime, so it's about, a little piece of this pen, the milliliter, or 13 centimeters. So I have 13 pens like this, all back to back. Meters. So I don't think the bee was 13 baseball bats long. So we're not going to go with meters. And I also don't think that it's 13 kilometers long because each kilometer would take me 10 minutes to walk from beginning to end. So I don't think that I'd want to do that 13 times and actually find a bee that size. That'd be craziness. So since we're talking about a bee, and bees are pretty small, they're not very big, I'm thinking millimeters on this one. Because even if I took this pen and I put 13 of them back to back, that would be a pretty long bee. So I don't think it's 13 centimeters. I'm pretty sure it's 13 millimeters. All right, we're good to go. We finished that one.